Hi guys, this is a three-phase brushless motor from a photocopy machine. You can see the back of it is rusted, although the label is pretty good, made in China from Japanese and foreign components. So it is 120 watts brushless motor. So guys, this is the controller that I have used many times. So guys, the connections to the motor have been done. Now it's time to run it. Yeah, as you can see that it is working fine and at just 12 volts, and this is a 24 volts motor. And guys, the same BLDC motors can also be used as an electric generator simply by connecting the two wires of the three to the multimeter. I will show you. And the output is going to be AC, three-phase AC. So the meter is pointing towards single phase 200 volts AC, and since it's a single phase, so I'm going to connect only two of the three wires. One will be left out. Yeah, the wires have been connected. Now see the meter screen. I'm running it and it is generating electricity. Yeah, and one wire is still open. So this is a big problem with the brushless motors when used as a generator, that the output is three-phase AC. So either you can use the three-phase output and connect a three-phase rectifier to convert that three-phase AC to DC, or you can simply use these two terminals as the single phase AC supply and leaving out one of the wires. That will reduce around 66% power of your BLDC motor that is being used as a generator, which is a bad idea. There is another third idea, which is you first connect a three-phase bridge rectifier to the output terminals of this BLDC motor generator, and then the DC out of that rectifier can be converted to AC with the help of a single phase DC to AC inverter. That has a lot of losses and also it is a little bit complicated. So what I'm going to do in this video is simply convert a three-phase brushless motor into a single phase AC generator. Okay, so let's get started. So guys, this is the stator winding of the brushless motor. You can see 1, 2, 3. These three are the three-phase output wires for the brushless motor, and this is the tapping point for the star connected winding, star or Y connected. Okay, so guys, the first step is to open up the tapping point, the star connected tapping point. So guys, the tapping point has been opened. Now let's proceed further. Now guys, the second step is to mark which of these terminals have been connected to this set. So I'm going to do that. So the meter is pointing towards resistance checking mode. So these three are not connected to each other because this tapping point has been opened. So one of the other terminal of this wire will be among these three. Yeah, the first group has been found. This one and this one. Now comes the second one. The second one is not this one, and which one is it? Okay, so second one is this, and obviously then the third one is going to be this one. So now it's time to connect them properly so that I can get single phase AC out of this BLDC motor when used as a generator. So guys, after successful pole testing and winding test, the wiring connection came out to be somewhat like this. This wire will be connected to this one, and this wire will be connected directly to this one, and the final output of this entire brushless motor generator will appear on this terminal and this terminal. Okay, so let's do that and then fit the entire system as it was before and then check if it's working or not. So first connecting these two together, and then these two. Okay. So guys, finally the wiring has completed. You can see that there are only two wires coming out from the armature of this brushless motor. Now it is no longer a motor, it can only be a generator. Okay, so let's connect the rotor magnet and see if it works or not. So guys, now it's time to test this newly made single phase AC generator, brushless. Pointing the meter towards 200 volts AC mode and connecting its wires to the generator. Check the multimeter screen. So yeah, it is generating 3 to 4 volts AC with hand rotation. Now it's time to test with some actual load. Now let's do the rope test. So yeah, let's measure the generated voltage. Keep looking on the display screen. "24 volts AC. Again. Around 28 volts. Now guys, let's connect an actual 12 volts load to it. And remember guys, the output is AC, single phase AC. Okay, so guys, the wire has been wound. Let's test it. Nice. Once again. So guys, since this generator is working fine, so now it's time to step up the generated volts with the help of a transformer and see if it can operate 220 volts appliances directly. Okay, so let's do that. So guys, this is a 12 volts to 220 volts computer UPS transformer that I'm going to use to generate 220 volts. So these are thick wires, so obviously high current low voltage AC will be connected over these two terminals and the output appliances will be connected on these two terminals. Okay, so let's do that. So yeah, the wires have been connected to the generator. Now it's time to connect a multimeter to the output terminals of this transformer on these two terminals and measure the generated voltage. It's pointing towards 200 volts AC mode. So let's first check the hand rotation voltage. Wow. Generator is working, it is stepping up the generated voltage. Let's see what the maximum I can get. 42 volts. 44. Let's see from here. So hand rotation voltage has increased obviously. So let's do some rope testing. Okay, keep watching the meter screen. Oh, the voltage was more than 200 volts. So let's move the pointer towards 750 and do the test again. Okay, keep watching the screen. 258 volts. Once again. Wow, nice. So guys, the generated AC is pure sine wave and it is much better than using an inverter from a battery. Now I think I can also connect motors and generators back to back for testing the output voltage and appliances. So let's connect some actual 220 volts load first. So guys, first I'm going to try this setup with just a 7 volts. Oh sorry, it's a 9 watts bulb. Okay, with a 9 watts bulb, LED bulb. Since this generator is of course very small, so let's test this one first. Okay. Okay, keep watching the bulb. Nice. Once again. Cool. So guys, this is a 200 watts LED halogen panel that I'm going to connect to this transformer and see if this single phase modified generator can handle that much load. So let's connect that. So yeah, this has been connected. Okay. Yeah, the halogen LED panel is working pretty good. Let's try once more. Nice. Now let's connect some other load. So guys, this is a power supply 220 volts to 9 to 24 volts DC. So I'm going to connect this supply to this transformer and see if this transformer can power up this 70 watts power supply 9 to 24 output at 3 amperes. Okay, so let's check that. So yeah, this has been connected, and now if it works, then this display will start indicating the voltage. and it's set at 24 volts DC, so here you should see 24 volts. Okay. Yeah, you saw that this is working too. So almost any 220 volt appliance will work with this setup with a single phase modified generator, as long as the power rating of that appliance is not more than 200 watts.